Alright, let's get our hands dirty. We are surrounded by an incredible world of machines. From the coffee maker that kickstarts your morning to the car that gets you to work, our lives are built on systems that whir, click, and hum. We trust them completely, right up until the moment they stop. That sudden, frustrating silence is a universal experience. But have you ever stopped to wonder why it happened? It's not magic, and it's certainly not just bad luck. There is a fascinating, beautiful science to failure, a story of energy, materials, and time. A hidden flaw or an accumulated stress eventually reveals itself in dramatic fashion. When we break things on purpose, we learn about limits, about forces, and the dance of parts in harmony. The same principles apply to the machines in your everyday life. A breakdown is a message about its design, its history, the stresses it has endured, a puzzle to be solved. Understanding this story is the first step to mastering your mechanical world. Let's start with the most common and intuitive type of failure: mechanical failure. This is the physical stuff. It's when a machine's body, its bones and muscles, gives out. Gears, belts, bearings, levers, casings. Mechanical failure happens when parts bend, snap, crack, or wear away until they can no longer do their job. Imagine two gears meshing thousands of times a minute. Each contact scrapes away a microscopic amount of material. Over millions of cycles, the teeth thin, the fit loosens, and a tooth eventually snaps under load. It's a long battle against friction. And given enough time, friction wins. Another major player is fatigue. Metal, like people, can get tired. Repeated stress cycles grow tiny cracks a little each time until a normal load causes sudden failure. A spinning shaft, a vibrating engine mount, an airplane wing in turbulence, all experience fatigue. The world is hostile to machines. Moisture causes corrosion, a reaction that eats strong steel into weak oxide. High heat makes parts expand, warp, or soften. Extreme cold makes them brittle and prone to shattering. Even dirt acts like sandpaper, accelerating wear on moving components. A machine's failure is often a story written by its environment, a long struggle against the elements. Now let's talk about the invisible world of electrical failure. The machine's nervous system. From the outside, it might look fine. Yet it's dead, or acts erratically. This is about the flow of electricity through wires, circuits, switches, motors, and tiny components. Think of electricity like water in a pipe. If the pipe breaks, flow stops. Vibration loosens connectors, bending fatigues wires, and corrosion on terminals blocks current. Even a tiny cracked solder joint can create an invisible gap that stops electrons cold. The opposite is a short circuit. Electricity takes an unintended shortcut, causing a surge. Surges can burn components, melt insulation, and in the worst cases, start a fire. Then there's component failure: capacitors, resistors, transistors. The tiny soldiers on a board. Power surges can kill, but more often heat and age slowly degrade materials inside components. Capacitors bulge and leak. A transistor stops switching. One tiny part can take down the whole device. Electrical failures are mysterious because they're invisible, but once you know the patterns, they make sense. We've covered the body and the nervous system, now the human operator. Human error is complex and unpredictable. This isn't about blame, it's the common point of breakdown. We get distracted, we forget, we misunderstand, and sometimes we get a little too creative. Every machine has limits: speed, load, and a correct sequence of steps. Overloading a washing machine strains the motor, belt, and bearings, drastically shortening lifespan. Using a wood bit on steel won't just fail to drill. You'll overheat the bit and risk the tool's motor. Many failures that look mechanical or electrical are rooted in neglected maintenance, human error by omission. Change oil, clean filters, tighten bolts, and lubricate moving parts, or face friction, heat, and seizure. During repairs, every piece matters. A wrong screw, missing washer, or pinched wire can lead to failure. Diagnosing a problem is the most critical part of fixing it. Knowing the category gives you a roadmap. No start? Think mechanical, electrical, or human factors. Timing belt, battery or starter, or lights left on. Describe symptoms clearly. A repetitive, high-pitched squeal that changes with RPM points to belt or bearing. Mechanical parts fail from wear and fatigue. Replace belts and bearings on schedules. Electrical connections fail from vibration and corrosion. Secure connectors and clean battery terminals. Maintenance is a proactive defense, not a chore. It saves time and money. Every failure is a data point, a lesson written in broken metal or fried circuits. Analyze the root cause, then iterate. Thicker walls, reinforcing ribs, better materials, better process. Create checklists. 1. Disconnect power. 2. Make connections. 3. Double check. 4. Power up. Be a machine detective. Eyes, ears, nose, and hands establish what normal looks like. New squeals, clicks, grinding, sudden heat, extra vibration. Early warnings you can catch and fix.